Hello my friend, happy to see you again now for this new section and mostly this new practical activity where we're going to build together the random forest regression. So this is our last model of the regression part and we're going to build it very quickly and efficiently because actually it looks very much like the decision tree regression model, so we will be very efficient. And besides, right after this section comes the most important section for you. It is the section where Kirill and I will explain to you how to not only evaluate your regression models, but also how to select the best one. So right after we're done with the random forest regression, we will actually have a new data set with, multiple features, like more a real world data set. And I will show you how to use your regression code templates to quickly plug your regression models onto the dataset and quickly find the best one. All right, so that will be very important for you to learn how to handle. But now let's smash our last regression model, the random forest regression. And before we start, let's just make sure everyone here is on the same page. I gave you the link to this folder right before this tutorial in the article, so make sure to connect to that link. And now we should all be on the same page, so we're all gonna go into part 2 regression. Then we're going to go this time to the last regression model, which is our random forest regression. And then we're going to start as usual with Python. And this folder contains, once again, the position salaries dataset and of course the random forest regression implementation in the IPYNB format, which you can therefore open with either Google Collaboratory or Jupyter Notebook. And as far as I'm concerned, as usual, I'm going to open it with Google Collaboratory. So there we go. Let's start implementing the random forest regression model. So now it is, laying out the notebook, and in a second we should have it. There we go. All right. So as usual, this is in read-only mode. So we're going to quickly create a copy so that we can re-implement it. We're not going to re-implement it from scratch because it is really similar as the decision tree regression model. So you will see that we will only re-implement one code cell. And if you come here in this regression folder for the first time with random forest regression, well, I encourage you to have a look at decision tree regression first, because indeed all these code cells were explained, right? But this time we're only going to delete this one. That's where we, train the random forest regression model on the whole data set, and then all the rest is the same. It is all the same as decision tree regression. We import first the libraries, then we import the data set. Then after the training of the random forest regression model on the whole data set, we predict this new result, which is the exact same syntax. Actually, I'm going to hide this now. So this is the exact same syntax as the decision tree regression model. And then here, that's the same. This is the exact same code that we implement to visualize the random forest regression results. All right, so let's just keep this because we did it many times, and I'm sure you're looking forward to that final section where, everything is going to make sense, because indeed you will learn how to use this regression folder containing all these code templates for regression, and you will learn how to understand which model to choose and, select the best one for your dataset. I will explain everything in this last section, but for now, let's implement that only missing code cell to train the random forest regression model on the whole dataset. So let's add a new code cell here, and now there you go. You could once again totally do it yourself by looking at some documentation online. And actually, well, let's do it together this time. We're going to pretend that, we would like to build a random forest regression model and train it on the dataset, and that I have absolutely no clue on how to build it, or on which scikit-learn class to use to build it. So let's see. Well, what I would do, as I said, would be to go to Google or Bing. So here's Google, and I would type here in the search bar, well, for example, scikit-learn, all right, and then random forest regression, this one, right? Even the suggestion helps, so that's perfect. Then pressing enter, and then I would go for the link of scikit-learn, the scikit-learn website, and this will usually be the first link, as it is the case right here. So let's click this, and normally I should find inside the exact name of the random forest regression class and also the name of the module that contains this class. And indeed, that is exactly what we see in big here. This is the whole library scikit-learn. This is the module that contains the class we want, and this is the name of the class. So there you go. Well, let's actually take everything here and we will adapt this a bit because this is not exactly what we have to write in Python, but I'm sure you'll know how to adapt this. There you go. That's what I wanted to show you. You know, it's very, very easy to find online the name of a class that allows to build the model you want, right? I just had to type scikit-learn and random forest regression and just go to the first link. So you see, very, very easy. So let's go back to our implementation and let's start building this random forest regression model and train it on the whole data set. So now I'm going to paste what I've just copied because indeed, in order to import this class, I simply need to add here at the beginning a from, right? From scikit-learn, and then from the ensemble module of scikit-learn, well, I'm going to import that random forest regressor class. And perfect. And now you know what the next natural step is. Well, it is of course to create a new object of this random forest regressor class. And we're going to call this object as usual regressor, which will be equal to, well, you know, an instance of this class. That's why I'm copying it and pasting it here and adding some parentheses. All right, so this time, do you think we have to input something in this class? Well, let's not fall into the trap of too much easiness, let's say. Remember that for decision tree regression, we actually did not input, you know, an essential parameter. We just input a random state factor in order to fix the seeds so that we can all have the same results displayed in the output. But this time, there's actually a parameter that is very important. I'm sure you guess which one it is. And not only it is important, but also you can tune it. You know, you can try several values of this parameter to see which value leads to the best accuracy and therefore the best random forest regressor. And that parameter is, well, of course, as you might guess, the number of trees. Because remember, a random forest is a bunch of trees teaming up to output a final prediction. You know, each tree makes its own prediction and then the random forest itself judges the final one to output. And so that number of trees is important, and that's why we will choose actually a number of trees here. And I usually recommend to start with 10 trees. So that's exactly what we're going to input here. The name of that parameter is n_estimators, just like that. And as we said, we're going to set it equal to 10. 10 trees, right? 10 estimators. Each tree is an estimator. Okay, and then as usual, we're going to add the random_state parameter. And once again, we'll set that equal to 0 so that we can fix the seeds and get the same output displayed in our notebook. Okay, great. And now, final step. You know this step by heart now. It is so obvious for you. It is, of course, to fit the regressor object to the whole data set. In other words, that means we're training the regressor on the whole data set, right? So here we have to add a dot and then fit applied to X and Y. Perfect. So, and that's all we had to do, you know, for this random forest regression implementation. All the rest is the same as the decision tree. So we can just execute all the cells here and observe comfortably in our chair the final result. So let's have a look. I just want to warn you again that it's not going to be pretty, and that's of course for the exact same reason as decision trees. A random forest regression model is way better adapted to high-dimensional datasets, or, you know, datasets with multiple features, which you will see in the final section of this part 2 regression, when not only learning how to evaluate your regression models, but also on how to select the best model for any dataset, you know, for a particular dataset you're working with. All right, so let's do this. Let's execute each of these cells, starting with importing the libraries. Then I'm not going to forget, I almost forgot to upload the dataset. You know, I was about to execute this cell, but that would have returned an error because indeed the dataset needs to be uploaded. So let's upload it now. All right, so as usual, we have to go into our machine learning A to Z folder, wherever you put it on your machine, then part 2 regression, then section 9 and last section of this part 2, random forest regression, then Python, and there we go, position salaries. This is still, of course, the same data set. Okay, so that's all good. Now we have the data set, so now we can import it inside the notebook, well, actually inside our Python program. And now we're gonna train the random forest regression model on the whole data set. So let's do this, and this will output the random forest regressor model with all the parameters. And at this stage, the only parameter that I recommend to tune is indeed that number of estimators, which we chose to be equal to 10. All right, and don't worry too much about the rest now. This will already give you an excellent model. And then now let's predict the final result by, just calling this predict method from our regressor object. And the predict method just has to take as input, well, that position level number 6.5, which, remember, you have to input in a double pair of square brackets because the predict method expects a 2D array as its input, right? So that's very important for you to know, but we saw this many times. I'm sure it has become also very obvious for you. So let's do this. Let's get this prediction. And we get a pretty good prediction actually, $167,000, which is very close to, that salary that this person mentioned to earn in the previous company, which was 160K. So that's very, very good. And now let's visualize the final result. Oh, I actually forgot to delete that output, but that's fine. Let's run the cell and we'll get that output again. And here is the regression curve of the random forest regression model. And of course, it looks like a lot the one of the decision trees, although this time there are more steps of the stairs. Remember, for the decision tree regression model, we had a step for each of the position level. And here, for example, we have 2 steps between 2 position levels. So that's, of course, because we have more trees this time and therefore more splits of, the features where you have the same prediction, the average of the predicted salary. So it only makes sense that there are more steps, right? Same here as well, and same here as well. But once again, this is not really relevant in 2D. I just wanted you to see still, the regression curve in 2D, which is the only way we can see it. Unless we plot something in 3D, over 3 dimensions, it's clearly impossible to visualize a regression hyperplane. So that's why I kept 2 dimensions here. But once again, don't worry. In this last section, we will have a real-world dataset with multiple features, and we will try each and every single one of our regression models on this dataset, and I will teach you how to figure out which one to select in the end. That's a very often asked questions in the data science community. You have all these models, but which one should you go for? Which one should you select for your dataset? And that's exactly what I'll teach you in this last section of part 2, regression. All right, so congratulations. That was your final regression model of part 2. You now have a complete toolkit of regression models, which gives you a lot of different options and solutions for your future data sets and future machine learning problems. So I'm really happy for you that we built together this toolkit. Make sure to use it the right way. And now we will finish with this last section to teach you how to use this regression toolkit the best way, by selecting the best model for any data set. All right, so join me in this next section. I can't wait to see you again. And until then, enjoy machine learning.